Hey guys, I'm chillin'. You know why I'm chilling? Because we're back to a review section. It's so nice. We have a nice straightforward section to end the chapter. This is section 2.8, graphing linear inequalities. It might be a shorter video if I stop just rambling. Let's get into it. The essential question is, how do I apply my knowledge of graphing lines to inequalities with two variables? I want you to recall something real quick, that an inequality is something like this. Previously, we had been doing it with one variable, and so I would know to graph this on a number line, and I would shade to the left. And the reason I'm using a open dot is because x cannot equal 2. If I had less than or equal to, then I would close the dot because x could equal 2. That's really going to help us with what we're doing today, because today we're now doing it in two variables. All right, I have an x, I have a y, but doesn't this thing look very much like a line? So as it turns out, in order to graph this inequality, I'm going to start by graphing the line. So let's do that. Let's see, I know my y-intercept is 1, and my slope is up 1, 2, 3 over 1, 2, 3, 4. And let's go down in the opposite direction. Down 1, 2, 3 over 1, 2, 3, 4. All right, so here's my 9. Now, here's the thing. Remember how in the last slide I said that if I had a less than sign, that would end up giving me an open dot? Well, in this case, points on the line are not going to make the line true. Just like for one variable, if I had not equal to, I couldn't actually plug in x equals 1, and I had to use an open dot. So for this line, if I have any points that are actually right on the line, they won't work. So I'm going to use a dashed line, and I can show you why they won't work in just a second. Let's pick a point on the line, and I'm going to show you why it doesn't make the line true. So this is the point over 0, up 1. Let's plug this into the equation. 1 is the y, 0 is the x, and this term goes away, right? Is 1 greater than 1? Well, no, it's definitely not. That's why I need to dash the line, because points on the line don't actually work. Now, I need to decide, do points in this region make the line true, or do points in this region make the line true? And the way I'm going to do that is by plugging in what's called a test point. Just like I just tested 0, 1 to see why the line was dashed, let's test the point 0, 0 to see if this region over here is the true region. Because I'm only going to be shading on one side of the line, kind of like in one variable, I only shaded to one side of the dot. So let's see what happens when I plug in 0, 0. 0 is the y, 3/4 is, 0 is the x. Again, this term goes away, and I have 0 is greater than 1. That's not a true statement. That means this point is a point that doesn't work. And since that point doesn't work, I can go ahead and assume that any other point, if I were to plug this into the line, any point on this side of the line would not work. On the contrary, points on this side of the line do work. And let me just plug in one point to prove it to you, but we're going to shade this side of the line. Let's plug in the point 0, 10 into my equation. So I'm plugging in 0, 10. 10 is my y, 0 is my x. Once again, the x term goes away. Is 10 bigger than 1? Yes, it definitely is, and that makes a lot of sense because this point is on the side of the line that does work. And that's today's lesson. It's as simple as that. Let's do just a couple more examples. Here I have a line where I would probably want to use intercepts method. So if I plug in a 0 for x, let's see, this goes away. I would divide by 4 to get that y equals 2. So there's a point that I can plot over 0 up 2. Plugging in a 0 for y, this point would go away. Looks like x would equal 8. So over 8 up 0, there's a point that I can plot. Now, unlike the last line where I wanted to dash it, now I have a greater than or equal to sign, which means that I can go ahead and draw a solid line, and I can make it solid because now, because of the equal to sign, points on the line will work. Again, though, I need to decide, am I shading up here or am I shading down here? So let's pick a test point, and you always just want to pick the easiest test point possible. Almost always you'll want to pick 0, 0 because, well, that just makes it really easy. So if I'm plugging in 0, 0, let's see what happens. 0 plus 4 times 0, is it greater than or equal to 8? Well, clearly there's 0 on this side. And is 0 greater than or equal to 8? No. So this is a point that doesn't work, which means, again, every other point that I tried to plug in on this side of the line wouldn't work. On the contrary, points on this side of the line would work. And if you don't believe me, literally take any point on this side of the line, plug it in, you will get a value that, instead of making the equation false like 0, 0 did, makes the equation true. Let's just do 2 more examples because I need to remind you how to graph horizontal and vertical lines. X greater than -2. Mr. Gregory, I have no idea how to graph this. I am totally lost. Let's think about it. X is always relating to -2. So I'm going over to -2, over -2, over -2. The Y could be anything, but I'm always going to an X of -2. Here's my line. It's a vertical line. So X is always a vertical line when it's just equal to or greater than a number. Okay, so in this case, since I have a greater than sign, I definitely want to choose dashed. Again, points on the line don't work. And people kind of freak out about this because they're like, oh, I don't know what to do now. But remember, you're just plugging in a test point. We're plugging in 0, 0. In this case, I only have X to plug in, and here the X is 0. Is 0 greater than -2? Yeah, it is greater than -2. That means that point works. That means every other point on this side of the line will work, so I'm going to shade that in. Awesome, I love digital ink, yay. Last problem. 2y is greater than or equal to 8. Let's put this into a form that I'm a little more familiar with by dividing through by 2. So y is greater than or equal to -4. Well, if x was a vertical line, wouldn't you think that y is a horizontal line? Yes, you would, because you're smart. And again, the reasoning is this. Every time I'm going down to a y of -4, it doesn't matter what the x is, it doesn't matter how right and left I go, I'm always going down to -4. I'm going to choose a solid line because it could actually equal -4. Points on the line will work. And again, let's plug in our test point of 0, 0. Here the y is 0. And is 0 greater than or equal to -4? It is. Throw a party and shade in the bigger half of the graph. I'm excited because I get to use digital ink every day with my job. How fulfilling. Hey, that's it. That was the quickest video we've had in a while. Here's a summary. Don't forget to plug in a test point. That tells you which side of the line to shade. All you need is a test point and you can figure it out. And don't forget that greater than without the equal to sign gives a dashed line, whereas greater than or equal to with the equal to sign gives a solid line because points on the line here work, points on the line here do not work. And that's it.